you can find me on Twitter or on GitHub by those handles. And today I will talk about observables and decide whether they are useful or hot or not. I am front-end developer at Scalac, so I will talk about JavaScript. And you can find those slides here, but I guess we might tweet about it on Scalac Twitter or Facebook or something. So, what is an observable? We can. Am I muted?
It's okay.
Okay. It's basically a stream of data, or can be considered as one. It's for a lot of front-end developers think of it like a promise on steroids. But what it basically is like a function that ties two beings, an observer and a producer. So producer gives the data, and an observer listens for them and can react to them. So how does it look like? Well, it's basically a function. It accepts an observer, which is an object with next, error, and complete methods on it, and returns a cancellation function. So we can tear down the logic that an observer set up. So how does it look like? It can be as simple as a function like that. We have a data source here, with the left hand, which gives us some data, which can produce an error and can be completed. And we basically tie those functions to our observer. And we return tear down logic to be able to release the resources and not produce memory leaks. So, well, enough with the theory. How can we use it? So, let's talk about coffee. How can we make coffee? It's basically a few simple steps. We can get the water from the tap. Then we need to heat the water. Then we can add some beans. And optionally, we can add some milk. But personally, I like the black coffee more. And we can code that. That's awesome. And we can do that with 3 different approaches. I will start from the most ancient one, which is callbacks. Then we'll move to promises, and then we will end up with our hopefully hot observables. So we can let's see how we can do that with observables, not callbacks. So we've got 3 helper functions, which basically every one of them accepts a callback, which will be called when the thing being done is done. And for the simplicity, it just sets a timeout of 1 second and after that it calls a callback. So let's go further. And this is the code that will make us coffee. With all those, after I think 3 seconds, we will receive the console message that the coffee is ready. But looking at this feels a bit like this. We've seen that. Most of us have seen that some kind of this code in the past. But we can deal with that with promises. So how can we do so? We've got similar helper methods functions here. They are just written in a promise way. So instead of callbacks, we actually don't pass anything in the parameter here. We just return a promise, which basically means that at some point we will get the water or beans, and the promise will tell us about it. And then with the code, it's now, as you can see, it's all flat. We don't have nested functions. That's because we can chain promises. So here we actually return another promise, but this is kind of moved here. So when this one resolves, we will get to this then, and the same one with the adding milk, and at the end we just return a white coffee. And the calling of it differs a bit. So here after calling a make coffee, we just wait for it to be ready, and then we print it out on the console. So this looks quite nice already, and don't expect, like for now, the observables will look pretty similar, but afterwards I will show some other use cases. So let's code the same thing with observables. We've got one helper function, just to avoid some boilerplate, which basically creates an observable, which will, in this case, produce only one value of v, and then we delay it for 1 second. And we basically create with this helper function 3 observables, which produce first hot water, then black coffee, then white coffee, and again function ready. So what does it look like? Instead of then, here, like we hit the water first, and then we use the pipe method on the observable, which allows us to basically put our data from this heat water observable through, let's say, a pipe of like a lot of operators, and at the end we will get our nice and tasty white coffee. So what's happening here? Like the stub function is just for logging out what we have in the middle of making a coffee. So here we would get a hot water console logged. Here we would get a black coffee, and here we will get white coffee. So the only weird thing here is a switch map, which is one of the operators provided by a library, which gives us the possibility to work with observables, which is called RxJS. And the switch map, basically, when we get the value from the heat water, it will switch to another observable returned by this function. So when the water is heated, we will switch to another observable, which is at beans. In this case, it works pretty similar to the then function, but it's, let's say, the then function does a lot of things implicitly. This way we say explicitly that we expect an observable here. I get that this might look a little bit weird in the beginning, but after you get used to the new syntax, it is super easy to think in this pattern. But what we actually did is we used observables in the same way as we did promises. But why? Well, we can do better. We can benefit more from it. And where do observables really shine? So when we have multiple data delivered over time, and we want to process them or react to them, like work in a reactive manner, that's where it really is helpful, because promises can only deliver one value, and in order to work with multiple values, we have to work around it. It gives us lazy evaluation out of the box, so unless we explicitly subscribe to an observable, nothing will happen. This is pretty tricky in the beginning, like you try to display something and nothing happens. This is mostly because we didn't subscribe. But from the other side, it doesn't consume the resources. And we have loads of powerful and really helpful operators provided by the library. We already used the switch map and the tap, which is just for performing some side effects. And here is a number of other ones. Those are from the which filter and map we can also find on arrays, so they are, let's say, less intimidating at first. And the others are also really helpful. I listed only the ones that I use the most, so because there's 100 of operators if you look at the docs. So let's come back to coffee. So I prepared an example which is basically an order board. It's really simplified so we can implement it in 15 minutes. So we can place an order, and as you might see, it's waiting in the status of requested. Nothing happens because there's no barista available at the moment. If a barista comes and clicks the button, it will start being processed. And if we click two times, 2 of the coffees will be done. And if we some baristas are really fast and click it ahead of time, the new orders will be processed immediately. So, and the third one won't be because there were only 2 baristas. So this is basically the code, and it's only 40 lines of code, so we can implement that, hopefully. Oh, this is already implemented. So first of all, we will create this button, which is pretty simple. Button add order. And to make it look nicer, we will style it with the some library component, and we can react to click events on it. And this is the first place where we will create an observable. So private clicks, and in this case I will create a subject, which is basically extending an observable. And I need to create a new subject. Import. And this subject has a next method on it, so we can push to it the click events. So clicks, next, and we can leave it empty. Click. It needs to be public. Okay, so if we actually, let's say, ng on init, on initialization of the component, we can subscribe to it, clicks, subscribe, and console log click. So now if we go to our sandbox and open a terminal, you can see that there's clicks, but yeah, that's nothing spectacular at the moment. I will just make it erased button. I've created a script for that. We can create coffee requests now. So in order to do so, requests, we get the clicks observable, which we already have, and we can put the data it produces through a pipe of operators. So in this case, and I already have a function that generates new IDs, so we don't have to spend too much time on it. But it just produces like 1, 2, 3 for every call. And then with this ID, we can create a coffee request, which is another coffee request. Like this. So at this moment, if we console log here, we can use tab for that. Console log request, and instead of, I think this is. Yeah, live coding is not a safe choice, but let's go for it. So now when it reloads, when I click, we get new orders, so we get new IDs, and we can now work with that to process our order and like make it assign status requested to it. Yeah, coffee make. So we get our coffee requests and pipe it again. And this time we will use a merge map, which is pretty similar to switch map, but doesn't switch map cancels the previous. I won't go into deep into that, but this will collect all the observables, all the data, instead of canceling the previous one. So if we click fast with the switch map, we will get only the latest request, and others will be abandoned. So we have a request, and we will assign a barista. Barista to our request. Yeah, we have to implement that function first. Function const assign barista, which takes a request and returns a new observable, which we then just delay for some time, delay for 1000 milliseconds.
Na dole masz podmieć R, barista.
Assign barista. Thank you. So now, if we subscribe to coffee making, coffee made, like actually it's, yeah. So if I click, after a second the coffee will be made. if we click a lot of times, it will make every coffee in time. And just what I talked before, if we use switch map, it will only, it will break. I didn't import it. Hello, okay. So now, if I click 3 times, only one coffee will be made, which is the last one. And the rest will be abandoned, so we have to merge, actually. Okay, so now, like in this, at this stage, we have 2 observables. At the end of this one will result in the requested coffees, and this one will result in coffee that are already made. So we can combine them together to update our statuses on our board. So to do so, let's create statuses, which will use a combine latest, which will basically, not like this. Sometimes the auto importing is wrong. And this is the deprecated one. Combine latest. What the heck? Combine latest, and we will get our coffee requests. I created a set status, so we can coffee request status. This will just add a status property to it, so we can distinguish them between each other later on. And the same for coffee making. And this is done, I think. No, this is, I think, making. Making requested, okay. And now if we print our statuses, which will be here as after I click, immediately we will get an error. That's awesome. Without map, search status already does that. So this is with RxJS gives us the possibility to implement our own operators, and this is an example of one. So yeah, it just takes the previous value and adds a status to it. Yeah. So okay, now we can see a weird bug that after we click, it yields immediately 2 requests, and this is because we subscribe twice to an observable, and it means that every time we subscribe, it will produce a new value. So in order to prevent that, we must share, actually I think we must share clicks or coffee requests. So this time, every time we subscribe to, even if we subscribe to coffee requests like hundreds of times, it will only create 1 request. So now we get 1 request after, yeah, and we can see that first it was requested, then it is status of making. And if we click it twice, it will do the same thing. So maybe it's time to display something. App coffee items. this is just for display purposes, so I want like to make it look nicer. So it actually expects items to be given to it, and and what we get here from our statuses is actually an array of requests. So we can try to start to put it here. This is just an Angular thing, a way to subscribe to this observable and yield the latest value to our component. So right now, if we click Add Order, we see that first it was put as a requested one, and then it is in a making status. If we add two others, okay, it basically gives us the latest one. So, but we want to only see one ID at a time. So to make this happen, we can operate on our statuses observable, which gives us the coffee requests and coffee makings statuses, and do like a reduce on that. So every time we get an ID that is already in our data, we will just update it. And there are two operators that do such a thing. One is reduce, which you might already know, but this will only produce a value once all the requests are done, and they are actually never done because we can always add more requests. So we must use a scan operator, which is basically a reduce that yields value over time. So every time we get a new value, it will produce another value. And the syntax is just like with reduce. So we get a state, which, okay, and we get the current value. And we expect it to return an object. So for every ID, we will update the element with ID of our current item and assign it to our value. Why is it not like, I need to put 3 dots here. And now it's maybe state is like, I don't know, reserved or something. Now it's working. Just to make the error go away. But now we actually don't produce an array, but we kind of get a map which maps IDs to our elements. So we want to map that. So we get our map, and we want to reduce over. Okay, we want to get its keys. So we basically want to take an object and convert it to an array for every key it has, which is some basic working on an array. We have a key, so we will map it to m of key, and then we will map it. We will basically So actually what we already did was create those two observables, and so we can go back to this stage. So when we add orders, it will stop at the making stage of it. So other statuses is just a matter of, in this case, repetition. So we create two additional observables and then combine. I used combine latest and I should have used merge. This is just basically continuing on the previous observable, and when we have the coffee assigned to a barista, we will make it, and then somebody will pick it up when it's done. All this does is just some delays. So I think we can fix this. Let's go back to. Now you cannot see what bullshit I'm showing you. So yeah, so we are again at this making stage. I was able to fix it, luckily. So now, in order to, after we assign a barista, we want to have the coffee done, which will be basically make a coffee. So this will be, let's say that making a coffee is longer, and then we just need to add it here to coffee done, 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 and just by adding a new observable, we can add new statuses here. So this will finish at the done stage, and now the only thing left is add a client that picks it up. So picked up, pick up, let's say it will be faster, pick up, so half a second, and I made it typo, picked up. So at this stage, whenever we place an order, it's going way too fast. Okay. We need to work on the coffee done observable. So now if we, let's say, create 5 coffees, it will make them using our observables. So now we can enjoy our coffee as a stream, and that concludes my presentation. So if you have any questions, please feel free to ask that, and thank you for your attention.